Hi, I'm Eduardo Montalvo, Applications Engineer with Coto Technology. In this video, we'll be doing a walkthrough of Coto's newest RedRock TMR sensor demonstration kit with part number RR1EK3-0003. This kit showcases our newest line of TMR sensors, the RedRock RR1EK2 product series. For more details about the sensors on this demo board, please see the description below, where we will add links to other videos, including walkthroughs of each of the various sensor types that we offer, their applications, and more. For the previous version of this board, with part number RR1EK3-0002, our previous walkthrough video can also be found in the description below. Now, TMR, or tunneling magnetoresistance technology, is rapidly becoming the go-to magnetic sensing technology in a variety of markets and applications. As with other solid-state solutions, TMR can achieve a much smaller package size with better reliability than a reed switch. And when compared to other solid-state magnetic sensing solutions, such as Hall effect sensors, TMR achieves much lower power consumption and higher sensitivity. So to illustrate some of the different variants of TMR sensors that we offer, we'll take a look at our RedRock TMR demo board.
To start, let's go over the contents of the RedRock demo kit. First, this demo kit comes with a small card that contains a QR code which leads to an online user guide that has more information about the sensors on the board, testing instructions, and more. Included inside the tin are 3 magnets that can be used to evaluate the performance of the various sensors on the demo board. First, there is a magnet attached to the inside of the tin that holds the demo board. This magnet's location allows it to trigger one of the TMR sensors on the board, which in turn controls power to the rest of the board. Once the board is removed from the tin, all other sensors will be powered on. This function mimics a wake-up feature, which is used in applications where a product's circuitry needs to remain in a low-power mode until it is removed from its packaging. Next up, we have a part that contains 2 axially magnetized cylindrical magnets inside a plastic holder. The magnets are arranged such that one end of the holder produces a North Pole field and the other produces a South Pole field. The holder has markers to identify the North and South poles, which I have colored black for this demonstration. This part can be used to activate a TMR sensor with a linear motion. The kit also contains a part that can be used to trigger a TMR sensor with a rotational motion. This part contains a diametrically magnetized cylindrical magnet inside. This part has a small peg that can be inserted into the various holes on the demo board and a post that allows the part to be rotated. This motion generates an alternating magnetic field at the location of any nearby TMR sensors. Let's move to the demo board itself and look at the various sensor types that are featured on it. First, let's start with the OMNIPOLAR digital TMR sensor, which responds equally to a magnetic field with a north or a south polarity. This type of sensor is active low, which means the output is high in the absence of a magnet and low when a magnet comes near it. On this board, we have 2 omnipolar sensors on the top with different sensitivities, 9 Gauss and 30 Gauss. We have also included a reed switch in between these 2 omnipolar TMR sensors, which allows users to compare the performance of these 2 technologies. The demo board has been placed on top of a printed version of the RedRock Demo Kit user guide, which has a grid where users can measure the activation and release distances between any of the magnets and the parts on the board. The markers above the board show where the linear motion magnet needs to be to activate the part below it. As the magnet is brought up to each of these markers, we can see each of these parts being activated. From this exercise, we can immediately see that the 9 Gauss TMR sensor can activate when the magnet is farther away. This TMR sensor can then activate at the same distance as the read or the 30 Gauss sensor by using a smaller and/or weaker and thus less expensive magnet. The omnipolar response, combined with RedRock's high sensitivity and low power consumption, which at its lowest can be under 100 nanoamps, makes this type of sensor ideal for a wide range of applications, such as proximity detection and device wake-up. Next up, we have a digital bipolar TMR sensor. As with the omnipolar sensors, this part is also an active low sensor, so its output starts high and it goes low when the part is activated. To activate the sensor, we can present a south pole on the left-hand side of the SOT23 package. Note how the sensor keeps its state until a north pole is presented in that same location. In terms of sensitivity, this part activates and deactivates with a flux density magnitude of 10 Gauss. This type of response is ideal for applications involving a rotating magnet, such as metering and motor encoders. To evaluate the sensor's performance with a rotating magnet, we can insert the peg of the rotational magnet holder into the hole next to the sensor. As we rotate this part, we can see the LED turning on and off, indicating that the sensor's output is being activated and deactivated with the rotational motion. As with all RedRock TMR sensors, our bipolar TMR sensors have low power consumption and high sensitivity. Furthermore, Coto offers several frequency options from 100 Hz to 10 kHz. Lastly, we have an analog TMR sensor. This sensor outputs an analog voltage that is proportional to the amount of magnetic flux density seen by the sensor. A set of 9 LEDs indicate the level of the output voltage produced by the sensor. When there is no magnetic field present, the sensor outputs a voltage that is half of the supply voltage, which turns on the middle LED. Once a north pole is presented on the bottom right corner of the demo board, the output voltage will drop towards 0 volts, turning on the bottom set of LEDs. If a south pole is presented instead, the output voltage will increase towards the supply voltage, turning on the upper set of LEDs. This type of sensor can also be paired with a rotating magnet to detect rotation speed and angle. The rotational magnet included in the demo kit can be used to illustrate this. The analog output response is great for applications that require accurate tracking of the position of a magnet rather than just a binary indicator of whether the magnet is near the sensor or not. One example of this is high-resolution liquid level sensing applications. All of these output options, combined with a small size, low power, and high sensitivity, make TMR sensors a perfect fit in any application that requires magnetic sensing. For a full explanation of how TMR works, or for more detailed information on each of these sensor variants, please check out Coto's other videos where we discuss the technology and each output response in more detail. For more information, contact us directly at appsupport@cotorelay.com.